Which one describes the reality much better?
What I mean by static is that the universe is not changing in large-scale structure over time.
Why still do we have a lot of distrust?
It's a complex question to answer. The trend in progress in artificial intelligence has had plateaus and then big jumps. And we're kind of in the middle of a big jump right now.
Hi everyone, welcome back to another episode of Thakkar Show. Today we have Professor Sam Fletcher with us from University of Oxford, another place I and many of us dream to be in for our studies. But thank you so much, Professor Fletcher, for giving us your time.
Yeah, and thanks for the kind invitation, Jay.
So a bit of background on Professor Fletcher before we dive into our conversation. He is a professor of philosophy of physics, which covers both the domain that I personally am interested in because I did my undergrad in physics and my master's in philosophy. So it is almost a dream match that I personally wanted to be in. So it will be a great reflection of my own academic journey and to see how much I can learn and gain from your expertise in the domain. And also, you personally started with physics as your initial passion, with a bit of math as well. And then how you suddenly went into physics. I mean, we talked that you were interested in history of science,
Yeah.
and then you dived into philosophy.
Mm-hmm.
So what part of philosophy or physics captured you and made you thought that this is I am personally also interested and passionate about?
I originally didn't think about it in terms of what aspect of philosophy of physics that I wanted to study. I wanted to understand the structure of reality,
Mm-hmm.
and I wanted to understand how we got to our knowledge
Right.
of that. So I was focused on these sorts of questions and not so much about whether these sorts of questions belong to this discipline or to that discipline. I was interested in whatever disciplinary resources would be
Right.
useful in answering these sorts of questions. And so I started off thinking about these questions in physics, and then as my studies progressed, came to realize that, in fact, it would be easier for me to answer some of these questions by studying other disciplines as well. So that's why I switched from physics as my undergraduate studies into philosophy as my graduate focus. But at the time, actually, as we were just talking about before, I thought, in fact, that history of science was going to be the best way to go in order to be able to answer these questions. But I got rejected from every history of science graduate program I applied to, and so I went into philosophy as a backup.
So what in philosophy made you think that even though this was a backup, but that turned out to be a great success?
Well, one of the things that made this possible was that philosophers are interested in examining questions with the highest level of conceptual rigor that's humanly possible. And they're willing to use any and all methods to do that. So what that means is that philosophers who are interested in physics and the foundations of physics need to understand the physics as well as a physicist does.
Mm-hmm.
And one of the reasons I was interested in this is that whatever approach that I wanted to take, it needed to make sure that it attended to all of the details about what we understand and what we don't understand. But the fact that philosophers are totally unconstrained in whatever means we use, we're really methodologically omnivorous, made it appeal to my own personal sensibility that, as I was telling you before, I don't really care what kind of disciplinary methods that I use, whatever is most appropriate for answering the questions that I find most interesting. Those are the methods to use.
What's the most interesting question you've been able to answer or you find very passionate answering?
Yeah. One thing that I was always confused about when I was an undergraduate studying physics is the use of the following phrase: "That's physical," or "Don't worry about that. That's unphysical." You might have heard this. You solve an equation, there's a bunch of solutions, you throw some of them away, you say, these solutions are unphysical, so we're not going to worry about them. And I learned to do that, to say those things without really understanding what I was saying or why I was saying it. So one of the questions that really interested me was, what is this reasoning? What is the structure of this reasoning? So in graduate school, I made some progress in understanding how to answer this question in the specific context of theories of space and time and gravitation. So I thought about it mostly in the context of general relativity and how people talked about what's physical or unphysical according to the general theory of
Mm-hmm.
relativity. And the account of physicality that I came up with is that physicists have an intuitive idea about which types of scenarios are physically possible and which types of scenarios are physically impossible, that kind of serves as a layer of judgment on top of what our theories literally tell us.
Hmm.
So, in other words, our theories in physics will often tell us a whole range of different possibilities. Lots of things are possible according to these theories, but we don't think that those theories are completely right about all of those. We think that it's too liberal in how many possibilities it allows. And so we have some intuitive ideas about what kinds of things really ought to be possible, and we use that to select some of those possibilities as being genuine, physical ones, and we reject some others as being unphysical. And
Right.
what I worked on a bit back when I was in graduate school was answering that and understanding the methodology for that, its justifications and its weaknesses also, in the context of space-time theory.
Interesting. You mentioned general relativity,
Mm-hmm.
and before diving into the main topic, I want to use this moment to ask the question that I have been thinking and unable to settle with an answer. Is when in general relativity we add time as a dimension, and you mentioned physical and non-physical. For me, the three dimension that we live in, which makes the physical world, is much more understandable for me to understand that okay, there are three dimension, because I consider dimension as the direction of the space coordinate.
Mm.
How do I add time in that?
Yeah, it's a good question, and indeed, many people are uncomfortable with what they call the spatialization of time in
Yeah.
physics, representing time in a way that makes it seem analogous to a physical dimension. Maybe I can ask the following sort of question. If you throw up an object just straight up and let it fall down,
Mm-hmm.
we can think about its height over time, and we can represent that as a parabola, right? Where the vertical axis is time and the horizontal axis um, is the height. So it's going to have a shape, right? Like that. Now, in that sort of situation, we have already spatialized time in a sense. We're representing time in a way that is analogous to how we're representing space. But whether or not this is a misrepresentation of the nature of time depends on what we take these representational tools like plots or the mathematics of differential geometry in the case of general relativity, what we take it to really be representing. My own view is that our mathematical models in physics are never fully complete. They're never fully representing every aspect of the things that we're interested in. And so for that reason, it allows general relativity to be an adequate theory of the goings-on in space and time, or space-time, even if we think that there's something fundamentally different about time than there is with space. Now, there's other ways in which time is differently represented, even if we use similar kinds of structure as we use for space. One is that things can move back and forth within space. But in almost all situations that we're interested in, there's just one direction that we move through time. Now, even that language, moving through time, is a metaphor,
Yeah.
right? Where we're understanding time a little bit like a location that we can enter into and to leave but never go back into. These metaphors, we always have to take care to understand that they're metaphors and they're not literal descriptions. But taking care with all of these things, I think, can help us help prevent us from falling into error in reasoning about the nature of time from our mathematical models of time and motion in physics.
That is interesting, but there must be a generally accepted definition of time to be able to use time in these contexts, because for for us, for me, my understanding of time and my usage of time is a lot more based on experience than a formulated measurement.
Yeah. So philosophers of time often will distinguish between mental time, or the time of experience, and the time of the natural world, or the time of physical phenomena. And in doing so, what they mean to do is they mean to distinguish two kinds of things that a complete theory of time ought to explain. It ought to explain, on the one hand, the way that time enters into our experience, and on the other, the way that time in a way that's not related directly to experience plays a theoretical role in our theories of natural science. So these two aspects of time, some people even regard these as two distinct concepts that just happen to have the same name confusingly. But most people think that they have to be related in some way. And so a full account of time needs to indeed relate these two. A full account of time, in order to do so, at least in my view, can't just be a physical account of time, but it also has to bring in cognitive science and psychology. Probably also history as well. And the reason why it has to do that is that in order to understand the nature of time experience, we need to understand the structure of experience and the way that our brains process the various stimuli and aspects of our memory as well. And the way that our memory connects with physical past events is in part the subject of history. So a full account of time needs to combine all of these together. It has to be a highly interdisciplinary endeavor.
Interesting, interesting. So now when we are discussing on philosophy and physics, how do we understand the difference between actually doing physics, which has its own wider spectrum from experimental physicist to theoretical physicist to to a different bunch of how do we do physics and how do we sort of give our best in the domain of physics versus doing philosophy on it. How do we understand that difference?
It's not like crossing a threshold or a doorway, where you go from a room labeled physics into a room labeled philosophy, or having those two rooms and trying to like stand awkwardly in between them. It's more like traveling from a valley to a mountain. It doesn't matter which is which. Where does the valley end and where does the mountain begin? There's no answer to that question because the boundaries of the mountain and the boundaries of the valley are vague, right? And the way that we refer to them doesn't uniquely pick out a boundary that separates a valley from a mountain. So, in the way that they shade into one another, or the one moves into the another as you traverse intellectual terrain, I think the best way to answer that, again, has to go back to the history of these disciplines. Now, if we were having this conversation improbably being recorded, say, 400 years ago, the answer would be natural philosophy is just a branch of philosophy concerned with the nature of the natural world. And it's just the same methods of philosophy applied to that.
Yeah.
Now, over time, over the course of the scientific revolution, those interested in natural philosophy developed their own culture of investigation and their own practices and their own institutions even. And that created a new human activity that branched off from this wider range of activities that was broadly called philosophy at that time into something that we now call science. And so if you think about it like an organism, like a biological organism, these things have what we now call philosophy and we now call science, including physics. They have common ancestors that are not too long ago did they exist. So the way that I would distinguish them has more to do with that history and their own institutions and culture that they've developed in the past few hundred years. We see that instituted in different degree programs at universities. And as a part of, and as a student in a degree program, you're enculturated into a way of thinking. You don't just learn facts. You don't just learn techniques. You also become a part of a community.
Right.
And learning how to do that is a part of coming to have an identity as a physicist or a philosopher. And that's as much shaped by the institutional structure of the contemporary university, which altogether is really a late 19th century, early 20th century kind of invention. It's not been around for very long. I think if we went back just a little bit further, even to the mid-19th century, the divisions between these sorts of disciplines were seen as difference in focus rather than a qualitative difference in study. But we can also answer your question in some detail as well. So these traditions now have their own methodologies now that are distinct from one another, their own techniques, their own bodies of knowledge that people are expected to know. So the way that you bridge the two is you're trying to find a question that the methodologies of each have interesting bearing upon. Or it might be a question in physics that is amenable to be addressed by philosophical methods. Or a question in philosophy, even, that has that is amenable to treatment using the techniques that physicists know. And that could be empirical techniques, or it could be mathematical techniques, or it could be conceptual techniques that physicists are aware of that are not so well known in philosophy. And you apply the one to the other. But to be able to do that, you need to be able to, how to say, code switch, right? You need to be able to take philosophy talk and bring it to physics or vice versa. And to be able to that, you need to be able to walk in each culture comfortably. And that's a part of what the training to become a philosopher of physics is to come to walk comfortably as much as possible as you can in each of these cultures.
From what I understand, I think it is parallel to how mathematicians and physicists work around. Eh, because mathematicians as a field and as a discipline is very distinct and different from physics, but then they overlap a lot when
Yeah.
it comes to their utility, their engagement with each other, and I think it is parallel to what philosophy of physics is right now as a different discipline itself.
Yeah, I think that's right, Jay. I think that they are really analogous in the way that you say.
We because you said about physicality and non-physicality.
Mhm.
Uh, we see a lot of theories coming up in physics as physicists try to understand the world through their own lenses,
Mhm.
and they try to make some predictions.
Yeah.
How do we sort of decide which one describes the reality much better? Because there's a huge gap
Mm.
between experimentally testing it versus understanding preemptly that these are the few which we need to give more focus on as they are more likely to describe the reality than the others. Because in one of my own podcasts I was talking
Mm.
with a CERN scientist who's working on antiparticles,
Mhm.
and he did say that antiparticles in general were predicted almost 50 years ago before they were first discovered in the in early 2000s, around 2012, I think Higgs boson was first discovered.
Mm. That
uh
that's right.
yeah.
Although antiparticles were discovered before that, but it's true that they were predicted many decades before
Yeah.
they were discovered experimentally.
So if I try to understand the 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 importance of philosophy of physics to see and understand which theory might describe the reality better, how do then philosophers decide or predict so that they can work on or philosophize on and then make more progress in that direction?
It's a difficult question to answer in part because the answer to it would resolve a big question within philosophy of science that I think philosophers have not agreed on. So there's not agreement on what these criteria are.
Mm-hmm.
Some philosophers think that ultimately the only thing that matters is empirical adequacy. That is to say, that the theories describe accurately the phenomena within their domain, and that everything else is window dressing. But there's others who think that, in fact, it's not just empirical adequacy that matters. There's many other factors that matter to the truth of a theory. Two theories, for instance, that are equally empirically adequate, but one that gives better explanations, many people think is more likely to be true. Now, but it raises two questions. What does it mean to give a better explanation? And why would giving better explanations make it more likely to be true? Maybe I can give you an example. So, back in the early history of cosmology in the 20th century, so applying general relativity to cosmological questions, Einstein was really one of the first people to do this. And he came up with a static model of a universe. In order for him to create this static model, what I mean by static is that the universe is not changing in large scale structure over time. He had to uh, he had to modify his original field equation. This is where he first introduced what we now call the cosmological constant. And at the time, it was considered to fit with what the observations of the cosmos we had, as little as we did. Part of the issue, of course, was that we didn't really have a lot of good observations until the 1920s and 30s about the overall structure of the cosmos. And even then, much more limited compared to what we have now. Now, Einstein thought that because there was a consensus that the universe was roughly static, that any theory any model of the cosmos that he produced will have to recover that prediction, but it will also have to show how that model of the universe is fits with all the other physics that we know about. At the time, when he first produced his static cosmology, he merely showed that you could describe it with having some matter content that is familiar, involving fluids and some electromagnetic fields. But it was soon discovered that his model had an unusual feature called instability. This is a feature that is the following. If the distribution of matter was even slightly different from what it was, instead of being static, the universe would collapse or expand. Now, it could well be that, in fact, as far as anyone knew at that time, the universe was static and the whole universe is on a knife's edge. But physicists generally felt that, and Einstein himself felt that was a poor explanation. Any explanation that you should give should be robust, they thought, under small variations in the observed phenomena. If you take that into account, the explanation that Einstein's model gives becomes very poor of the observed phenomena. So that's a kind of an example of the way that physicists reason about what counts as a good explanation and what doesn't count as a good explanation. This robustness or stability idea is one of them. However, this doesn't answer the question, ultimately, about why can't the universe be on a knife's edge. I don't think that question was ever answered in this early debate in cosmology. Why can't it be on a knife's edge? But there seemed to be some consensus among physicists that it shouldn't be. And insofar as there was this consensus, there was this agreement that the explanation that Einstein's static universe gave wasn't good. But there are these further questions that remain unanswered. So these are the sorts of things that you can use to try to decide between different theories that are equally empirically adequate about whether one gives a better explanation than another.
What is better explanation for you personally? What things do you feel that I need to know and have? Rather, it can be the direct empirical evidence, or it can be even indirect evidences, to see if the parameters considered are robust or not. So, uh, what kind of robustness you think makes it makes it work for you personally?
Yeah. You phrase that in a very nice way, because instead of me saying, well, there's disagreement among philosophers as to what this counts, you ask me personally what I think. So that's a very, very clever way of doing it. So for me, I think that an explanation is going to be good, at least in part, to the extent that it renders something expected or expectable. Here, there is a little bit of a subtlety, because we do think that we ought to be able to explain rare events. And by their very nature, rare events are things that we can't be expecting. But I would say that when we do explain rare events, the way that we explain them is by rendering them substantially more expected than they were before. So, for instance, vaccines. Very, very rarely someone has an autoimmune reaction to a vaccine having to do with some ancillary components that are used to formulate the vaccine. One of these, I believe, is called Guillain-Barré syndrome, and it happens very rarely, much less than 1%. I think it's 0.1, 0.01, maybe even less than that. But its outcomes, its symptoms are unmistakable, and the circumstances when it happens make it such that even though having this syndrome, having this autoimmune reaction is very rare, it still becomes the most probable explanation of the way that someone's body is behaving. So I think that a good explanation needs to render what's to be explained to be more expected, or even altogether, all things considered, expectable. I think a good explanation also shouldn't add in extraneous bits.
What do you mean by that?
Let me give you an example. So suppose that you asked me, how did you climb the stairs? I could say, well, I just put one foot in front of the other. Or I could also say, as I put one foot in front of the other, I was thinking, I wonder what Jay is going to ask me. He's going to ask the questions in order, or is he going to go in a different direction? I wonder what Jay's video equipment is like, and on and on and on. You would say, and I think rightly, you don't have to add any of that stuff. That stuff is irrelevant, right? And maybe it tells you a little bit about when I was stepping, I wasn't stepping with as much intent as I would be if I was just focusing on walking up the stairs. But it adds a lot of stuff that is completely irrelevant. So it makes the explanation worse because it doesn't make it proportionally more expected in comparison with the complications that it adds. So a good explanation also should be only as complicated as it ought to be.
Fair enough. Fair enough. Because my next question was to was to know more about your work that is mostly you've done on statistical reasoning.
Yeah.
You gave a very nice example of COVID.
Yeah.
And we've seen a lot of example of people showing massive distrust on vaccines,
Yeah.
even though statistically vaccines were much more safer. We had a lot of statistical data to show that they are much more safer in comparison to
Yeah.
the fear that was there
Yeah.
among people, which caused a lot of distrust. What do you think as in understanding the philosophical foundations of these stats? Why do we still have distrust even when we and vaccines, taking this vaccines example, we this was not the first time any vaccine was created. A lot of disease were eliminated completely from regions because of vaccines. Having proof of concept, having been taken vaccines for different medications, having statistical evidence or statistical support uh, to show, why still do we have a lot of distrust?
It's a complex question to answer, and it's a good one. Medical psychologists are interested in this question, and they've investigated the different sources or reasons that people give. And the reasons are varied, and they're not the same in every place. Different populations and groups of people have different reasons for being, I think the technical term in the literature now is vaccine hesitant. And the reason why they use that term vaccine hesitancy is that it's not generally the case that people are distrustful of the statistical evidence. Some of them are. But some of them, they don't think that they have any better evidence than the evidence that the medical experts are giving them, but they're hesitant for other reasons. So not all of our decision making, especially our intuitive decision making, is based on a weighing of the statistical evidence as to whether or not a certain immune response is going to occur. The kinds of things that people use in their decision making also have to do with things about will this have other effects on
Mm-hmm.
me that medical researchers haven't been paying attention to? How do I know whether they've been paying attention to them or not? If the vaccine had been around for a long time, they might reason. This is just one example, of course, right? They would have heard about weird or unusual side effects that maybe medical researchers hadn't thought to look for before.
Mm-hmm.
Maybe some of these side effects only appear after a long time after you have the vaccine. That would be another thing that you'd be able to learn about if the vaccine were around for a long time. So when it comes to new vaccines, I think these are some of the reasons that people might have. And the reasons why they might have them have to do in part with the new technology that was used for the COVID vaccines. So it wasn't produced in the usual way that most vaccines are. It's a new technology that hadn't been used to produce vaccines on such a large scale before.
Right.
So this hesitancy has sources like that. There may be also other sources that don't have so much to do with the evidence at all,
Mm-hmm.
having to do with questions about, do people I respect endorse it? Is this something that people in my social group do or don't do? Would they approve of it if I took it
Mm-hmm.
or not? Those, of course, affect people's decisions as well, aside from assessments of the evidence.
Right.
So one thing that people who work in scientific evidence, and especially statistical evidence, have known too well because they've had to deal with it since the birth of modern statistics at the beginning of the 20th century,
Mm-hmm.
is that there's a big difference between assessing what the evidence says about a hypothesis and deciding how to act. Because you can assess what the evidence says about a hypothesis without understanding what kinds of consequences different actions will have. Assessing the evidence tells you about what you think is likely to be true, but it doesn't directly tell you about what the consequences will be if you act on that truth or not. Those sorts of investigations are important too, but they're not investigations that are the subject of statistics directly. They're the subject of, indeed, policy, economics, but also moral and political theory as well,
Hmm.
because it involves assessing what the values and risks are of various sorts of courses of action. And these are ultimately economic, political, and moral questions.
Now, when we're talking about people and their distrust with commencement of AI, where is AI is prominently hallucinating a lot because when we use AI, when we even ask AI to share references of its research, the data that AI gives to us is very likely to be hallucinated in some sense or the other because AI is not trained to say, "Oh, I don't know, I couldn't find." Now, with that hallucination coming in with AI and society being more dependent on AI, with the distrust that we already talked upon, the distrust based on politics, based on the socioeconomic positioning of the society, do you think we as a society needs to rethink of our understanding and trust on how we perceive statistical data and how we analyze them? Because we humans also are very likely to hallucinate on a lot of statistics, uh, and that is very small, but it may have impact with upcoming of AI, which sort of may give more hallucination on important topics and important decisions.
Yeah, the you're right to point to how most large language models are not designed to convey uncertainty. They're designed to predict, right, the most likely response to a question based on an enormous corpus of text and other information like that. So, on a technical level, there's some people working in AI who are trying to develop means for large language models to express uncertainty. Now, commercially, it's unclear whether this will ever work because it's not really clear that it's in the interests of the companies always to have the level of certainty of the large language model expressed. And there's some technical questions as well as to how to transform the likelihood or probabilistic prediction that the model makes to a level of certainty. Maybe I can give you some examples. So
Yeah.
you ask an everyday question to a large language model, like, how many species of banana are there? I don't know the answer to this question, right? It will give you some answer, right? If you ask it in a slightly different way, it will give a slightly different answer. It may give you the same number, but it may phrase it differently. When do you count these two different answers, even though they have the same content, as being enough the same that all of the different predictions like that should be counted as one? So in other words, each output, can be very distinct. And together, they may combined have a large probability. But how do we know how to combine them? There's a technical question here. Because if you don't combine them, it might be that the answer that it gives to that question is quite low in probability. And so you might think that would have to say that it's quite uncertain. So there are some fundamental questions about the technical architecture of large language models that makes it difficult for them to express uncertainty in a helpful way. However, it might be that question can be overcome. If it could be overcome, I think that it could fix one of the big bugs about large language models, because
Right.
instead of hallucinating, it's quite possible that they would have as an option saying, I just don't know, I don't have enough information, or something like that. It's not yet clear whether or not that will be technically feasible. But if it is possible, it could solve that problem. Now, as to whether before this problem is solved, if it ever is, this is leading to more distrust. Gosh, I think it's too early to tell, because things are changing so quickly and people are adapting to the technologies at different rates with very different kinds of reactions. It's hard to see what it's going to lead to.
Right.
I feel like I have enough uncertainty that I can't make a prediction, unlike an LLM, about what's going to happen.
Thinking on this terms, do you think that if we as a society needs to perceive an information, and the perception of the information should be in a satisfactory manner, then the parameters should be beyond the statistics? Because I think if we can if if the satisfactory rate of an information goes beyond just statistics, it goes on, I mean, the same banana example, like the species. Okay, they say if let's say AI gives me there are let's say 24
Mm.
species. Okay, 24 species, okay enough because I have a number, I have a stat. Now, if the information goes beyond 24, if it gives me much more context on the first ever species to be dated was in, let's say, 5 million years ago, uh, and from there and the latest one was, let's say, through some genetic intervention, it was around 30, 40 years ago, for example.
Mm.
Now that gives me the stat is still there. The stat is the stat is even wider, but among the widening of the statistical response, I have a bit more context to it. So do you think, other than simply depending on the stats, the perception of stats through context will make the perception of any information, it can be either AI, or it even can be in as sensitive things as vaccines, giving more context with not only stats but maybe with much more different domains would make it more trustworthy?
I think it will make people trust it, but I'm not sure whether it'll make it more trustworthy. The reason for this is that we are used to, in conversing with people, the correlation between the ability to give detailed context and true knowledge. In
Mm-hmm.
other words, talking to someone without using any large language models, if someone can really, in a detailed way and repeatedly, right, give contextual information about everything they say, you think, oh, wow, this person is a real expert, right? Now, the judgment that they're a real expert isn't necessarily because you or I are also experts and we actually agree with what they're saying, is that there are patterns of ways that experts respond about the kinds of structures, contextualizations that they give, that we find highly correlated with expertise and trustworthiness. And so when we see that in an LLM, we do the same. We trust it in using the same, but the underlying mechanism in an LLM is not the same as the mechanism in the mind of an expert. Because it's very easy for a large language model to completely hallucinate all of this contextual information. Very difficult for a human to hallucinate it. They have to be trained to be able to give detailed answers that are not true and to
Mm-hmm.
do it repeatedly. And that's such a rare skill, a skill that is not so useful that we encounter it and have to guard against it so often. You can think of this sort of perception of trustworthiness,
Mm-hmm.
the thing that's causing people to trust, as a kind of cognitive hallucination themselves, right? You can think of it in analogy with other kinds of illusions. So you might have seen examples of illusions like on Instagram or Snapchat or whatever, where people do these drawings, for instance, chalk drawings,
Mm-hmm.
like on the sidewalk, that look like there's a huge pit or a swamp or things jumping out and so on. And if you're at the right angle, it looks totally realistic, like there's a huge pit. But it's just chalk, right? So just like how these drawings take advantage of the architecture of vision to make things seem like they aren't,
Mm-hmm.
LLMs can take advantage of the architecture of our verbal and textual interactions to make it seem like it has something that it doesn't have. To make it seem, in other words, that it has expertise. But what we understand as expertise has to do with the structure of the cognitive architecture of someone who has certain kinds of experience and training that by their nature LLMs can't have because they're just different kinds of things. So I think these sorts of things make people trust it, but they don't make them trustworthy.
This is really interesting because the reason I changed the focus of my own podcast from general experts to academics was this. Because general experts would hallucinate by. It's almost like if I can say something confidently, it is believable.
Yeah, yeah, that's right.
But
That's right.
it may not be true. And I think that's how before before the scientific information was spreaded, I think that's how superstitions were spread across societies in earlier times. When someone said something confidently, it looked believable. People believed, and that's how superstition might have formed. And I think we are now with AI, we have maybe given the authority to create superstition to an artificial intelligence model who can create superstition based on globally available data, which can make it look more believable than true. Then what? How do we distinguish between a believable information versus a true information without having an academic expertise or having enough background to distinguish it?
Yeah, it's not always easy. But if you think an analogy with the other kinds of cognitive illusions that we can have, you can think of strategies. So with the chalk drawings, for instance, they only work when you look at them from a certain angle. And if you look at them from another angle, it becomes completely obvious that, in fact, there's no pit there, it's just some chalk on the pavement. A kind of thing that you can do with LLMs, which is a little bit analogous, is try asking the same kinds of questions by adding in information that you think is irrelevant into the prompt to see if it makes a difference. One of the things that should be the case for an expert is that if you add in irrelevant information, it's not going to change substantially what the answer is. The trick with this, though, is that you do need to know a little bit about what could be relevant and what couldn't be relevant. Now, with the pavement chalk drawing, everyone is enough of an expert in vision because everyone who can see uses it quite a bit to be able to very quickly know to take the strategy to step sideways. But oftentimes people are asking questions of LLMs they're asking questions on topics that they don't have any expertise. And so it can be hard to know what would count as relevant and what wouldn't count as relevant. So there it is a lot harder. But if you know, this is another thing you can do. If you know that you're asking about a question on which you don't have expertise, you should start your initial skepticism level much higher than you normally would. And merely take what you're given through the LLM as, despite how confidently it might say, as possibly indicative hearsay. So if you don't have a strategy, in other words, to try to check it, to see whether it's robust, whether it's stable, to do a callback to the nice example from the history of science with Einstein's static universe that we were talking about before, is to start your skepticism level higher than you normally would.
Right.
And if you do that, you won't too rapidly change your opinion erroneously. Now, to adapt the strategy, though, you have to be willing to go slowly. You have to be willing to not be satisfied at getting quick answers. And I feel like a lot of the folks who use LLMs for these purposes are doing so because they really feel pressured that they need answers fast. If that's right, then we'll have to think about why people feel so compelled. It might be that the problem we're facing is not a problem about LLMs, but a problem about society more broadly.
Right. That is really interesting because from my own usage of LLM, my interaction with LLM is mostly it's almost like I try to stroke it. So let's say if LLM gives me, I'll take the banana example. If LLM gives me there are 24 species, I will go and say, maybe define the storyline of what is your source. It will give me the source.
Mm-hmm.
If I have enough time, I might go and verify each source and see how much is
Yeah.
hallucinated or not. But let's say if I do not have time, nor do I have uh, enough cognitive capacity to open every source mentioned,
Yeah.
what I would do is then I would ask more and more questions. I'll try for an LLM to narrow down to the point that I specifically know and I'm confident about. So if I'm confident about, let's say, banana having potassium, I'll take the species answer to trace if LLM can come up with the exact answer of banana having potassium or not.
Mm-hmm.
Just a vague example what
Yeah.
I'm giving, but I would try to take the answer of LLM into the domain I know and I'm confident of to test the process behind it and then use that as a starting line to develop things on top of it.
Yeah. I think the risk is that the LLM may be correct about the things that you know about, but not correct about the things you don't. Now, if this were a person and they were, as it were, drawing upon the same set of the same knowledge base and cognitive tools, and so when they're responding confidently about something and you want to know, does this confidence really reflect expertise? You can see whether when they respond confidently about other things, whether it reflects expertise. But with LLMs, the mechanism is totally different, right? The way that it is responding to each of these is not by drawing on different channels of expertise, but by finding the most probable answer to a question based on its corpus. There's other minor modifications and technical things, but that's basically what it's doing.
Right.
And so if the follow-up questions that you're asking are things for which it has a lot of text in its corpus, it will answer just as confidently and also accurately about those things if it's accurately represented in the corpus. So, so this is another way in which a technique that would work if you were cross-examining a human expert would work, but it's not obvious that it would work as well
With
with an
LLMs.
LLM, yeah.
Interesting.
What I would like is I would like to see some empirical data on people trying these strategies. If we have some empirical data, we would be able to know better what kinds of strategies are more reliable or not. I don't
Right.
have expertise in that, so I don't know whether anyone has tried that or not. And it's a difficult thing to do because the software versions are being continually updated. And so it's hard to know, in other words, whether data that someone has collected on these sorts of questions really reflects current models or not.
Right.
So this is a challenging question to address.
Right. Right. Interesting. Right. And also, we're not sure if the companies who are updating the models have been working in these contexts and have data and are willing to share that.
Indeed, indeed.
Fair enough. Interesting. So, moving on to back to physics,
Yeah,
uh, we talk a lot about uncertainty principles, quantum mechanics, which itself is very famously perceived that if someone claims to know quantum mechanics, they are lying. How much then, as a philosopher, when these things are really hard to testify, uh, in real world, how much of it should we how much of it should would they create an impact uh, in technology? Because quantum computers, I've been personally hearing from a decade
Yeah.
that quantum computers are developing. They are mostly trying to work on the possibility of having 0 and 1 together as a bit rather than using 2-bit space.
Yeah.
So, how much of these will have a real impact in the world?
It's hard to predict because if we look at analogies with other technologies that people have been talking about similarly, we see many different kinds of outcomes. So, a classic example that people have been talking about is since mid century, since the 1950s, people have been saying that fusion energy is just a couple of decades away. It was a couple of decades away in the 70s, it was a couple of decades away in the 80s, a couple of decades away in the 90s, and it's a couple of decades away now as well. Now, you don't have to be a scientist to see what the trend is.
Right.
On the other hand, when it comes to artificial intelligence,
Mm-hmm.
in the 50s and 60s, people were thinking, well, maybe it's going to be within the next 40 years that we will find. Turing himself thought that we'll be able to develop a general artificial intelligence by the end of the century. I think he was probably wrong about that, but the trend in progress in artificial intelligence has had plateaus and then big jumps. And we're kind of in the middle of a big jump right now.
So, from what I understand, is the next big thing we can expect in physics is to actually understand if our idea, or to more than understand, to clarify our doubts on understanding of what dark matter is and is it really there or not, and if it is, and how it influences and functions more precisely.
I hope so. If I had to make a prediction about what the next big advance would be, well, maybe I don't know if I would predict that this would be the one, but this is the one that I'm hoping for.
Interesting.
I think it has, combined with its potential to be resolved and its potential impact to be together, the one to have the highest expected impact, I think.
Interesting. So, at the end, I just want to know your experience of this podcast, of doing this podcast, and if you have any questions for me at the end.
I think the experience has been very smooth. I myself don't produce these sorts of things, so it's been interesting to learn about the production side of it from you. Maybe my question to you, Jay, is what do you hope to accomplish with your podcasts?
So if I have to, if I think from a marketing perspective, I can summarize it in one line: is to make research go viral. Because, as I mentioned, a lot of experts go on famous podcasts and talk about things and promotes more hallucination and misinformation. So, with this podcast, I want to accomplish is to actually give my audience the example and the conversations which helps them learn how to think. Because what we had a conversation of, what my takeaway from our conversation on and off camera is, more than the information is how you think,
Yeah, that's right.
how you identify a problem from a statement, how you dissect the problem, and what approach you take to solve that problem. And every expert, based on their domain, have different training
Yeah.
and different approaches to them. And every approach is unique but important in itself. So I want to accomplish this thing as my podcast, and information is is a source, is a more than a source. It is a method of doing that. Because if I simply go and take a lecture on how to think, I don't think people will be interested.
Yeah,
But if
that's
they
right.
listen to conversation, if they hear a question, and if they hear a question being answered in a certain way, they're more likely to engage, more likely to understand on how to solve a problem, how to think of solving a problem.
It's very sensible, and it sounds like a great approach as well.
Thank you, thank you. And genuinely, it's really an honor to be here in Oxford, and that too in Merton College, which is almost 800 years old.
Almost, yes.
Almost 800 years old, where people here started thinking of planets and orbits before Renaissance. So it has its own history, and thank you for inviting me here and to talk to you and giving us your time. It's really an honor.
And thank you for setting everything up, Jay. Very much. Thanks.